thank you, then you've got different densities, which makes a difference. If you've got a piece of metal or a blob or a lamina, and it is half aluminum and half steel, then you got something totally messed up. All right, you can't find out where the middle is because of the two densities. So that's where rho comes in. All right, so write those down, and then the moment that goes in the denominator is rho times the antiderivative from a to b of f of x dx. And all you've got to remember is this part right here. What is the moment around the x-axis? It's the moment around the y over the moment. What is the moment around the y-axis? It's the moment around the x over the m. If you remember this, and you have those two integrations written down, then all you got to do is plug and chug. But if you don't remember that basic thing right there, if you don't remember this, then all that other stuff ain't worth crap, because you're going to put this over this for the x, and you're going to put this over this for the y, and you're going to have everything bass what?
Backwards.
Bass backwards. Some of y'all might need to look that up because of your parents. All right. All right, let's take something simple. I've got this one in my book. In my notebook right here. Find the center of mass of a semicircular plate of radius r. And that's all they give you. All right, so find that, and they give you the function. F of x is equal to that. So take that and see what you can do with it. And I'm going to try to find you another example. Can y'all see it? Hold on.
Yeah.
I'll make sure I don't want y'all to be deprived of the picture.
Oh, now we can see half the problem.
What? It's only a sentence. Find the center of mass. You're going to have to stop that coughing. You don't have to get well, okay? Okay, there's one I got. Find the centroid of the region. Yeah. Yeah, that's one. This one, the one I've got here, is one where you have a line going across it. So this one's easy, and the next one's going to be a little bit more difficult. All right, common sense time. I'm going to ask y'all a question. If you have something that's symmetrical, and you're wanting to find the center of the mass, or center mass, if something is symmetrical, then basically it's the same on both sides, right?
Yeah.
So if it's the same on both sides, then one direction, you're not going to have to figure the center of mass. You can just plot it algebraically. And in this case, where's my... In this case, the symmetrics is around what? The x-axis. The y-axis. Here's the symmetry. Line of symmetry is right here. Now, if the line of symmetry is right there, then you know that your center of mass is going to fall on this line as far as x goes. Okay? So your x is going to be for your center of mass of the triangle, or not the triangle, the whatever this is called, semicircle. All right? Your x is going to be 0. So you don't even have to figure that. Or I'll figure it for you. 0. You're welcome. So now we got to figure the y. We got to figure this. So that's going to be 1 over pi r squared from negative r to r. Negative r to r of 1/2 dang old this squared. So plug and chug. Y bar is equal to 1 over pi r squared. Help me out. Make sure I didn't. Is that pi r squared? Area of the circle is pi r squared? Or would it be 1/2? It'd be 1/2, wouldn't it? You could put the 1/2 in there, or you can divide it by 2. It doesn't matter. From negative r to r of 1/2, and plug in the square root. Where is it? Square root of r squared minus x squared to the second power and dx. And that's probably what they did on the next page. Yep, they did divide it. I figured they did. Or you could divide it by 2. Whichever one you want to. That'd be 1/2 right here because it's a semicircle. So now clean this up. Because that's all you need to do is clean it up, because you're going to rewrite this as r squared minus x squared to the what power? To the 1/2 power. And then what's 1/2 raised to the second power? 1. So that takes care of that. The 1/2 comes out, and it'll cancel out some of that stuff. So you basically got a easier problem than you think, especially when you clean it up. So that's going to give us, let's pull this 1/2 out. Let's pull it out here. So y bar is equal to let's see, 1/2 over 1/2 pi r squared, and the 1/2 do what? They cancel. So that leaves us with 1 over pi r squared times the antiderivative from negative r to r of r squared minus x squared to the 1/2 power raised to the second power dx. And that's going to give us y bar is equal to 1 over pi r squared of negative r to r of r squared minus x squared dx. And they're basically going to use implicit differentiation. Let's see. But that's going to be, you can break it up into two if you want to. So I'm going to break it up. Y bar is equal to 1 over pi r squared, antiderivative bracket, antiderivative from negative r to r of r squared dx minus antiderivative from negative r to r of x squared dx. And what do we do here? That's not rhetorical, I'm asking y'all. What's the antiderivative of x to the 0 power? X to the first over 1, right? So that's going to come out to be r squared x right here, right? But we're leaving something out. What's the problem? What's the problem there? Huh? dx. There's an r there. What do we got to do? You still got to take, remember doing implicit differentiation? I know this is not differentiation, but what do you have to do since it's integration? No, I'm not asking, I mean, that's not rhetorical, I'm asking y'all.
Implicit differentiation.
Hmm?
Did you say implicit differentiation?
I said it's based on implicit differentiation. In other words, think about it. I mean, the derivative of r squared is what?
Just right there.
2r. Okay, but you got to think. You got to think in terms of going in the opposite. Let me move that over here a little bit. Hold on a second.
You're 1/2.
All right, what happened? Why did that 2, where'd that 2 come from? You don't know? Okay, well let's just erase it then. We don't need it.
Sounds good.
Y'all suck. Well, think about it. You're taking 1/2, that's r to the 1/2, and then you got to make up for that 2 in there. That 2's got to be, that 2 is a makeup. In other words, there's a makeup in there, and you got to put that in there. Why? I mean, right here, there's no 2. Happened when we were doing it happened between here and there. Say again? They just stuck it in there? Huh? They messed up. No. Well, we took the antiderivative right here in respect to x. The 1/2 canceled.
They changed the interval when they
Did what?
They changed the interval.
Yes, they sure did. What did they do? Remember doing that? U substitution? Could they have done U substitution? Well, let's say U is equal to R squared minus X squared. I'm just talking out loud. Or right here. You can use U substitution here. I'm just... They did something here, and like you said, the 0 to R changed. It was negative R to R. Could they have said, okay, well, we're just going to do it from 0 to R and multiply it by 2? Could that be what they're doing? Why would they do that? Make it what? Make it easier. That's what they did. Now, wouldn't it have been beneficial to y'all to have seen that? Or had a little note out here? Yeah. So that's where the 2 comes from. Alright, now that you know where the 2 comes from, now finish it. So, y is equal to 2 over pi r squared of, well, here's our, be what, r squared, let's do this, and that'd be r squared x, right, minus x to the third over 3. Somebody check my antiderivative there. And that's going to be from 0 to what? R? Yeah. 0 to R. And now just plug R in. And then you get your direct proportion. So plug R in. And that's going to give you a 0. 0 is going to cancel that out. 0 is going to cancel here. You're going to get 0. 0 is going to go away. So y bar is going to be equal to 2 pi r squared, parentheses, r squared times what? R minus r cubed divided by 3. And then when you crank all that out, it's going to come out with some kind of related rate. Y bar is equal to 2 over pi r squared times r to the what? R to the third minus r to the third over 3, which that will give you 3r over 3, which will be 2r over 3. Lord, I hope I did the algebra right. Let's see. Let me copy this. Hold on.
2R.
File, copy. Oh, I can't do it. I got to. This thing is so screwed up. I can't copy. I have to go to file. Edit. Copy. And then change screen. And now I can do paste. Sorry about that. This technology is really user friendly. Alright, let's see if y bar is equal to 2 pi r squared times, what do we get? 2r cubed, dang old 3, and r squared will cancel with this and leave r. I got 4r over 3. Somebody help me out.
4R, 3 pi.
4r, oh yeah, 3 pi, sorry. 4r over 3 pi. So, first of all, remember that symmetry matters. I don't know how to spell symmetry. Is that right? Yeah. Symmetry matters with center of mass. Okay? 2, get y bar. Get x bar and y bar. X bar and y bar. You don't have to worry about too much about m, because the m is going to be what? Your mass is added together, so that's not a problem. But now, what if you got something like this? And I know it's getting close to time for y'all to go because some of y'all are having heart attacks. Let's go with something like this for y'all to work on. Find the centroid of the region bounded by 4 minus x squared and g of x is equal to x plus 2. So basically I'm going to give you what it looks like. It's going to look something like this. That's supposed to be 4. Sorry. Can't draw. There. That right there is 4. And looks like so they want to know what the center of mass of this area is. Now you can look at it and tell it's going to be somewhere what? Right in here? You can look at that and tell, but you got to tell me what the actual, and you're going to have to dang old take antiderivative, dang old f of x minus what? G of x. That's the starting point. Because you've got to get this region isolated. That's the first step. So, and that's going to be from -2 to +1. And then y'all can take off from there. Okay? Alright, let me get the roll. And I'll put some homework up and I'll extend your other homework. So don't worry about that because I'll probably extend your other homework till this Saturday. Something like that. I got to keep y'all behind the 8 ball somehow. Right? Try to discourage you as much as possible. I'll try to fix it to where it was cut off Saturday. You're welcome. And I appreciate the visit. All right, how many people we got here today? 1, 2, 3, 4, 5, 6, 7, 8. Are you missing some people? Mr. Fowler. He relies on the videos and the work side of the book.
Whatever works.
Well, he did that with Cal 1, so, and he did the work. Let's see, today's Thursday. Oh, I got to put y'all down for not here last week or last time. They'll mark y'all absent, even though class was canceled. Wasn't class canceled Tuesday?
Oh, yeah.
Oh, yeah. All right, how many people we got? It says 8. All right, Fowler's not here, so I'll go ahead and mark him not here. Anybody else? Let's see. 1,
These
2,
2 guys
3,
sit right here.
6, 7, 8, 9, 10. 2 guys. Okay. I know some of y'all's names, but All right, Alexander. Huh?
Yes.
You're sick. Yeah. Bowling. Corwin.
Here.
Fowler's not here. Mealer. One of them's Mealer. Osland's here. Robinson's here. Urban's here. Vaughn.
Here.
Williams. Y'all have a good day, and I'll post the homework here in just a minute. Hopefully you'll be discouraged by the next time I see you.
Probably trying to see what happens.
Oh, I got somebody hit my button for me. It's the one in the top right on the back. Silver. Just hit it one time.